Okay, so we're going to be looking at polygons that have the same shape but different size. Can you guys think of anything that is the same shape but different size? Instruments. Which ones are the same shape but different sizes? I'm sorry, what? Violins and cellos are the same shape, but one's way bigger than the other. What else? Coins. They're all circular but different sizes.
Shoes.
Shoes. They're all the same shape but different sizes. Chloe? A what? Those aren't quite the same shape though. Not all calculators are the same shape.
Tires.
Tires. They're all round but different shapes. You can say a golf ball and a basketball, definitely same size, different shape. Was that yours?
iPhones.
Okay, iPhones. Okay, because those don't change shape. They don't change shape. They just change size. Okay, so what we're going to be looking at are things that are the same shape but different sizes. So let's go ahead and draw. Today we're gonna look more specifically at triangles. So I'm gonna draw two triangles. I'm gonna call this one ABC and this one DEF. So if we're going to be able to say that these are similar, two things have to be true. So if ABC is similar to DEF, all corresponding angles would have to be congruent. So if we look at corresponding, what do you think corresponds with A? D. What do you think corresponds with B? And what about C? F. Okay, so in order for us to have similar figures, corresponding angles are going to be congruent. The second thing is that corresponding sides are proportional. And that word proportional is where cross multiplying will come in to help us solve for side lengths. So do you guys remember what a proportion is? When you have two fractions equaling each other, or two ratios equaling each other. And so what we call that ratio is we call it a scale factor. So have any of you guys ever heard of scaling up or scaling down? Not climbing, but like taking something and shrinking it, or taking something and enlarging it. Where have you seen that before, or heard of it? Have you guys ever heard of Yep, they do. Okay, has anyone here looked at a map before? So do you guys know, and have you ever noticed in that bottom corner they usually have a line and it'll say like this long equals, that's a scale. Okay? Krista, can you go back to your seat please? That's a scale. So what that's telling you is that this length might really account for 100 miles. And so what it's done is it's scaled down everything to that measurement. We also can scale things up. Like, you can think balloon sizes. If you're blowing up a balloon, you start small and then you just scale it up, up, and up until it's done. Okay, so when we look at the scale factor, that's the ratio. Whoops, I totally screwed up my space. Scale factor. We're looking at the ratio of lengths of the sides in similar polygons. So if I were to put up here that AB was 5 and that CD was 15, what would our scale factor be? So in other words, how do we get from here to here? So we would take, if I was starting with this one, so this is our old, this is our new figure after we scale it, you're going to take new figure and divide it by old to get your scale factor. So 15 divided by 5 means your scale factor is 3/1 or 3 times bigger. Okay, that's what scale factor is it's the ratio that'll get you from one figure to the next. How this might look in an assignment, if it doesn't tell you, like this one, I didn't tell you until I wrote it which one was my start and which one was my end. If it doesn't tell you, then you pick the order you want to go in. Okay, but if it tells you that you're starting here, ending here, you're going to do new over old. The last thing I want to do right here is go over the notation. So triangle ABC, oops, triangle ABC is similar to triangle DEF. This symbol right here is the symbol for similar. So when you see that, it means that they're similar. It's a lot like the congruence, but without the equal sign. Yeah. There already is one set of lights off. When we turn off both, people fall asleep. Let's see. Okay, so at this point, this is the basics of everything that we're doing today. So we're going to start with trying to find scale factors and then use that to set up a proportion that we can cross multiply and solve for x. So everything we're doing today is about setting up, learning how to set up the proportion, and then the solving is just your cross multiplying that you did last night. Okay, so let's start with just being able to match up like sides. So here I'm going to draw a triangle JKL, and I know that it's similar to triangle PMN. And we're going to identify congruent angles and write proportions of sides. So there are our two triangles. Yeah. Lazarus, next time just pack up and wave at me. So the first thing we're going to do is we're going to look at the angles to see can we match angles to angles. So in our picture, what do you think goes with what? Which angle do you think goes with which one? L and N? Why? What made you think L and N?
Also, like they're both the same.
Okay. Anyone else think they know a pair? K and P. All right. How are you making these guesses? Tell me what's going through your heads when you're making these. Okay. They are, but what you have to look for is one of these is actually like a rotation of the other. So if we were to rotate this smaller one and line it up here, L does go with N, what would K go with?
M.
M, and J would go with P. The other way that you can know is by the statement itself, just like in chapter 3, Jay, how we had triangle congruence and we matched up our vertices based on the statement. We can do the same thing here. So J would go with what? J is first.
Oh, J would go with P.
Would go with P. So that means angle J will be congruent to angle P. Okay, what would angle K go with?
M.
K would go with M. And then L will go with N. So because we know they're similar, we know corresponding angles will be congruent. And we can find the corresponding angles the same way that we did back in chapter 3 with our congruent statements. Okay, the second thing that we're going to do is write the proportion of sides. So again, we have to pick a triangle that we're going to start with and a triangle that we're going to end with. So are we getting, do we want to go small to large or large to small?
Small to large.
Okay, because it didn't specify, we can do whichever one we want. So if we're going to go small to large, that means small is my old, large is my new. So I'm going to make a note to myself. Because to do scale factor, what do? New divided by old. So we're going to put new on top, old on bottom. Okay, so new figure. Pick a side. Any side. MP. So what's the corresponding side to MP over here?
K.
Ooh, no.
L.
Okay, so let's look at PM. That's the first two letters. So what does it have to match up with over here?
JK.
The first two letters, JK. Then I'm going to go to another side from my new figure. So what's another side over here? PN. So over here, what matches with PN? JL. The outer two match with the outer two. And then our last side, NM, that would have to match with KL. This right here is how we're going to set up our proportions. It's a matter of matching up sides that go together in a fraction, and then we'll solve for whichever one's missing. Okay. So could we have, if we switch this up, could our fractions all be flipped? Yeah, you're going to get the same answer if they're flipped. It's just a matter of how you set it up and making sure that you're consistent. So all one triangle is on top, all of the other triangles on the bottom. So this is what we call the proportion of sides. Okay, any questions at this point on just matching like sides and like angles? Sarkis. NM. And so just remember that this is actually kind of a rotation. So if we were to rotate this around, we would get it to line up. Do you guys remember any learning about dilations?
Yes.
Or what it is at least? Do you guys remember what it is?
Yeah.
What is it? It's something that makes it bigger or smaller. That's what similarity is. A similarity is just a dilation. It's taking a factor and either making it bigger by that factor or smaller. So everything we're doing is a dilation, but we might have to rotate it so it matches up. Okay, so the next three that we're gonna do, we're solving for the variables in the picture. So I'm gonna flip the page just so I have enough room. And so we're gonna actually set up our proportions, and then we're actually gonna solve them as well. So in number 2, if triangle DEF is similar to triangle HJG, solve for X and Y. So this could be what one of your problems looks like. Yeah.
For like example 1, is there going to be questions where we just like set it up like that?
Okay. That's what number 1 and 2 on your homework are asking, is just to set them up.
Okay.
You're not solving anything because you don't have enough information to solve. Okay, so when we look at this, the first thing we want to do is write out the proportion of the sides. So pick one that you're going to start with and one that you're going to end with so we can stay consistent. So which one do we want to say is old and which one do we want to say is new? First one's old. Second one's new. Okay, so if it doesn't tell you which one is your starting and ending, you get to choose. And so all of ours are going to be new over old. So HJ, what side corresponds with HJ over here? DE. And again, we can use our statement to help us. JG, EF, and HG, DF. So now what we're going to do, now that we have our sides proportioned out, we can plug in what we know each side is. So HJ is 15, DE is 9, JG is Y, and EF is 14, HG is X, and DF is 12. So this is now plugging in the specific parts to our problem. Which one do we actually have numbers on the top and the bottom for? 15 and 9. So that one, this 15 and 9, that's your scale factor. That's how much you are increasing or multiplying the small one by to get to the large one. But we do like to make sure it's reduced. So 15 I can reduce by 3, and so we get 5/3. So that means if I wanted to scale it up, I would just have to multiply every side by 5/3. So then what we're going to do is we're going to use this scale factor, 5/3, and we know that it has to equal y over 14. So we're going to set each one of these fractions that has a variable equal to the scale factor. Cross multiply, and then divide by 3, we get y is 70 over 3. Do the same thing with x. And we get 3x equals 60, or x is equal to 20. This is what we're doing on more of our problems than just listing out matching parts. We're setting up the proportions using scale factor and cross multiplying to solve for x. So I took this here and just rewrote it where I had room to figure out what my scale factor was, because that was the only fraction I knew numbers on top and bottom. So when we reduced that, we got 5/3. So then I'm going to take this 5/3 and I'm going to set it equal to this, and I'm going to set it equal to this. So that's how I set up these two equations. So I set the scale factor equal to each one of these separately so that I can cross multiply and solve. Because in this statement, we know that all three of these have to equal. So the 5/3 has to equal this, and the 5/3 has to equal this. Yes, ma'am? We're actually going to leave it as a fraction, because if we change it to a decimal, it's a repeating decimal that goes on forever. So when you round it, it's not quite accurate. So let's keep it as just the fraction. Okay, we're going to do another one where we're solving for x. So here we're going to be told if triangle AGM is similar to triangle KXD, solve for x. So here we're only going to have one letter to solve for. So AGM, this side's 32, this side is 36. Put that on the wrong side. It's supposed to be this one has x plus 6. So again, when we start this, we want to start by figuring out what are the sides that go together. So which one do we want to call old and which one do we want to call new? Huh?
Small one.
Is what?
Old.
Let's do a large one for old. It really doesn't make a difference, but gotta switch it up. Okay, so then when we set up our sides, we'll go XD, we'll go with GM, because XD is the last two, it has to go with the last two. KX, so that's the first two, that'll go with AG. And then lastly, we'll have DK. That'll go with AM. So that's your proportions of all your sides. So now, do we know anything about DK or AM in our picture? Do we have anything? Summer, do you think we have anything for those two sides in our picture? No, they're blank. So so what I'm going to do is I'm just going to cross this one off because we're not going to use it. We don't know anything about that side. But what do we know about XD? It's x plus 6. What do we know about GM? It's 36. What do we know about KX? It's x plus 3. And what do we know about AG? It's 32. So what do you see there after we've plugged in the side lengths that we know? You should see a proportion. And then how do we solve a proportion? Cross multiply. So let's go ahead and cross multiply. So 32 times x plus 6 equals 36 times x plus 3. 32x plus 192 equals 36x plus 108. So that's what we get after we distribute. I need to combine like terms on either side, so I'm going to move the 32x to the other side of the equation by subtracting it. Same thing with the 108. I'm going to move it to the other side of the equation by subtracting it. And we'll be left with 84 equals 4x. So x is equal to 21. And that would be your answer. So if they don't give you information for all three sides like we had in number 2, you're just going to set up the proportion with what you do have. And once your proportion is set up, you cross multiply, get whatever you're solving for, x, y, a, m, whatever the letter is. Okay. Any questions on that one? Either the setting up of the proportion or the solving. Sarkis.
I still don't kind of get like how you like find xd is over gn or like.
Okay. So first off, you need to figure out which ones are new and which ones are old.
Okay.
If it doesn't tell you, and we'll go over an example where it tells you so you can see the difference, you choose. So just label one old, one new.
Okay.
So I'm going to take aside from my new one. So I chose XD to start with.
Okay.
I'm going to find over here the corresponding side that goes with XD. If I can't tell by looking at it, I can go up to my statement. So XD was the last two letters. It has to match up with the last two letters. So that's how I knew it was going to be GM. And it's just like we did when we did them with congruence statements, same way.
I see.
Okay? And so then we just did it for each one. Okay, we have one more that I want to go through with you that's like one on your assignment. Number 4. If triangle JKL is similar to triangle MKN, solve for X. So what do you notice about this one? It's what? Huh? I just can't hear you. We don't know it's a midpoint. Okay, but we do have overlapping. One's triangle is completely inside the other. So when we had overlapping triangles, what did we do? Anyone remember what we did when we had overlapping triangles? We separated them. So that's going to be what we do here, is we're going to draw them as two separate triangles. So that way we can see more clearly what we have. So there's my small one, and I'm labeling the sides that I know. And then I'm going to do my bigger one, KLJ. (3x minus 2). And then I'm not sure, what is the length of KL?
32.
How'd you get 32? It says 20.
So you have to add both sides.
Why do you have to add both sides? Okay, so the reason I want to make sure we go over this, 20 only goes from N to L. If we want all of this, we would have to add the two together. Whenever you have overlapping triangles like this, you're either going to have to add two numbers or subtract two numbers to find one of the lengths. Sometimes they'll give you the whole length and they'll say that's 32, and then they'll say this is 20. So how do you find this one? You would subtract. So depending on what they give you, you may have to add or subtract numbers when you have overlapping triangles to find a missing length. Okay, so now that we have our triangles separated, we can go ahead and write out our proportions. So which one do we want to call new? Which one do we want to call old? Huh?
The big one new, the big triangle.
That's old or new? New. Okay, so we're going to go from small to large. So then we'll take KL. That'll go over KN. LJ will go over MN. And then I'm not going to worry about writing that third one because do we know anything about those two sides? No. So I'm not going to worry about that third one at this point. So now I'm going to go, now that I have my proportion set up with corresponding sides, I'm going to plug in the values that I know. So KL is 32, KN is 12, LJ is 3x minus 2, MN is x plus 1. Now we have our proportion that we can cross multiply and solve. I'm going to give you a little tip here. If you can reduce your fractions before cross multiplying, it'll make your numbers smaller so you don't have as big of numbers to work with. You won't get a different answer, you'll get the same answer. But I'm going to reduce these two numbers so I can get some smaller ones to work with. So when I reduce them both by 4, I get 8 over 3. So when I go to do my cross multiplying, I'm going to have 3 times 3x minus 2 and 8 times x plus 1. So it just made my numbers a little bit smaller so that I can work a little bit easier with it. Then I'm going to bring my work over here just because I'm running out of space. 3, I'm going to distribute the 3 and distribute the 8. And now we're going to solve by moving the 8x and the 6. So we end up with x equals 14. Okay, any questions on that one? How to set up the proportion or solve it?
I don't know if you have to add or subtract. Like what says KL?
So because these two, I was given KN and I was given NL. So in order to get the whole length, I had to add them. If we look at, on your homework, if you look at number 18. Do you see how on 18 on the side SZT, the side that has those 3 letters? Do you see how it tells you that the whole length from S to T is 40, but then ZT is 5? How can we find SZ? 40 minus 5. So it all will depend on what they give you if you're going to add things together or subtract. Okay. Okay, any questions about the setup or solving? Okay.